Hello everyone and welcome to another tutorial, and we're going to talk about how to generate thinking particles and how to troubleshoot them, see what data is available and so forth. So this will serve as a guide for you to work with thinking particles if you wish to do so. I'm not going to show you how to do something very specific, just how to look into and control some of the parameters like generating them and reading what attributes each particle has. And very soon I'm going to make a nice little fire and smoke tutorial. So without further ado, let's look into how to generate and troubleshoot thinking particles. Let's begin with an empty scene in Cinema 4D. So first of all, I need somewhere to hold my espresso, and I'm going to go here and create a null. Let's call this espresso. Excellent. And let's create an espresso tag. Fantastic. And now let me do some nice little things here. I'm just going to close this so it's in its default state. First of all, let me just dock this over here. The next thing I need to do is go to my simulate thinking particle settings, dock this down here. And third, because we're going to need the console, I'm going to go to script console, grab the console and put it right here. So I have all the interface elements I need to work here. If you want, you can save this layout. You just go to the windows. Oh, you know these things. Anyway, so let me show you how to generate thinking particles. So if you go to right click and go to thinking particles, you will see all these lists, but of course you can go over here to the left and twirl open the system operators, go to thinking particles, and you will find all the generators. So in TP generator, all the generators. We're going to talk about the p-born, the p matter waves, and the p storm, but mainly the p-born. So let me just drag this in here. The p-born is the simplest, the most basic way to create thinking particles. So we'll just add it, and you can see in the attributes we have a birth type of count, we have count, rate, and shot. You can always go right click here, go to the help, and it will give you a full overview of what everything is. Just so that you know, count means the maximum amount of particles in your scene at any given moment. Rate is the amount of particles that are born every second, and this is the amount of particles born every frame. Anyway, we're going to keep it at shot, and let's add 2 particles. And they have a life expectancy of 90 frames, give or take nothing, so all particles will live exactly 90 frames. I'm going to extend this to something like 250 and just drag this over here. We have 250, and let's check out and see what happens when I press play. Nothing really happens here. You can see 1 particle, but if you look at the total number, you will see that it goes up to 180. So rewind again, you will see it goes all the way up to 180, but we're seeing only 1 particle. That is because the p-born just generates particles based on this and assigns a life. So because this is set at 2 particles per frame and the life is 90 frames, at 180 particles, that means that we have been generating particles up to frame 90 times to 180, and then for every new particle that's born, 1 dies. So the first 2 die, that gets it down to 178, and then 2 are born up to 180 and so forth. That's why it stabilizes at 180. So the total number of particles when you're using the shot or the rate is in combination with the life. Whereas when you're using the total count, it's mainly the total count and the life. Anyway, just go and read up on this. I shouldn't have to tell you these things. Okay, let's continue. Let me show you how we can read data from particles in order to troubleshoot any possible scene. And I'm going to use something from our system presets. And if I untwirl this and go to the string folder, you'll see it says print to console. I'm going to drag this in here. And basically this is a little coffee node that allows us to print things in the console. And I'm going to drag the particle here. It won't work, of course. And the reason is that the particle itself doesn't have any printable data. So we need to do something differently. And we need to use a node, let me turn this on, that's called get data. So if I write data here, it will filter. I'm going to go to pgetData. And what pgetData does is you tell the pgetData which particle stream you're going to use. And currently, it's every particle that's been born, because we've connected the output of the generator. And if you go here, you will see that we have all the possible attributes a particle can have. There's a way to add custom attributes to a particle, but that's for another tutorial. So we do know that the only attribute which is currently associated to every particle is the life. So that's the only one we can read. Let's go to life, and let's command double click here and here just to maximize the little nodes. Let's drag this in the input, and I'm going to nudge this forward 1 frame, and you can see we have 3 and 3. So you can see the total particles are 4 because 2 are born when we are at frame 0. For the new particles that are born, we get the printout. So let me delete this, and I'm going to move forward, and we get 2. And 3 stands for seconds, because life, if you hover over here and you look down here, you will see that life is a time parameter, and time is normally seconds. So we know that each particle has a life expectancy of 90 frames. Because we are at a 30 frame per second scene, by default, that means that the life expectancy of each particle is 3 seconds. And that's fantastic. So if I go and add, for example, a bit of variation, about 25%, now you can see that we don't get 3 anymore. We get a number which is lower than 3, and it can be about 25% lower than 3 total. So let me get rid of this, and we're going to see these 2 numbers. So now we have a sort of a random life with a maximum of 3 seconds and up to 25% less than that. This is what this means. And this is how we print the data. Now here's the question. Every time I advance here, you see we get more particles, but I only get 2 more, and 2 more, and 2 more, and 2 more, and so forth. So this is okay if what I'm trying to do is just read the life expectancy of each particle upon its birth. But what if I'm trying to do some sort of operations where every particle that is already alive, in this case all 14 particles, we need to do something with them? And here's one of the fundamental principles when working with Espresso and Thinking Particles. Each one of these little groups of nodes, I will call it a loop or a subroutine or something. And it runs through and does whatever it has to do, and then it moves on to the next one. If I want to read the totality of particles, that is something I will not do when they are born, because this is telling the pgetData to supply the printer console with the data of the particles which are born on each frame. I want to go on each frame and read out the data of all the particles in the scene. And to do that, I'm going to type pass, not auth, pass, and get the p-pass. The p-pass, it looks at all the particles of a particular stream or group, as it's called. A particle group is what is called a particle stream, and by default it's set to all, which is the default group. All particles belong to the all. Now if I expand this, you will see there is no name associated to this output, and the way to do that is just go in here, right click, and go to the ports and say show names, and now we can actually see the names. So if you want to read at each frame the parameter life of every particle in the scene, you need to go to a p-pass and connect this to the particle input of wherever you're getting the data from or wherever you're writing the data to. Let me turn this off. Let me advance, and now you will see we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I think this shows 16 because the 2 previous ones, I don't know, there is something about a small lag. I think it has to do with coffee or the console itself, but anyway, this gives you the life expectancy of every single particle. So let's remember the first numbers. 3, 2.834. Let's play one more time. 3, 2.834. So because of that lifespan is being set when this guy is born, each particle is born, that means it's going to retain its life expectancy, well, for the rest of its life. Okay, so although it's a variable, each particle holds that until we either change it or the particle dies. And what do we say? The The particle is dead, long live the particle, something like that. Anyway, so this is how to read data. Now, talking about loops, so let's go and try something, okay? Let's go and try something. And what I'm going to do is just disconnect this and this. One thing you need to know is that when the printer console is connected, regardless if the console is closed or open, so if you have a few 100,000 particles, it will be extremely slow. So keep it here, connect it when you need it, and disconnect it when you don't. So let's go and do something. I am going to birth my particles. Okay, there you go. Give birth to my particles. And then I'm going to go through all the particles that have been born. And I'm going to assign a value. Now, the pGetData is to read data out of each particle. Then we have the pSetData. So type set, which is equivalent. And in this one, we don't read. There's nothing here. We write data. So I'm going to say for each and every particle, let's go and write something. Now, what can we write? We can write alignments, we can write colors, we can do all sorts of things. Let's go and change the position of the particle. Okay, so let's go and change the position of that particle. Now, how would I go and do that? Well, first of all, I need some sort of number. And if you hover over here, you will see it needs a vector. So let's go here and say constant. A constant, if you select it, can provide any number, unchangeable number. So you change this to vector. And what I'm going to say is I want my vector to be 100, 0, 0. So I'm going to put this here. And when I press this, you will see that the particles move here. And that's all it does. The particles are born, and in this loop here, command double click, in the second loop, they actually get moved over here. Now, because they're all in the same position, I want to differentiate this ever so slightly. So we need some sort of number that is different for each particle. That number can be the particle index. The particle index, and if you want to know what a particle index is, what I'm going to do is just put it here in the input, turn this off, and advance by 1 frame. You will see it's a number from 0 upwards, up to the total number of particles, and -2, because again, we are missing the 2 particles that were just born anyway. So now we have this number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 which is just an integer, just an ID of the particle identity. So each particle has a unique name, and its name is a number from 0 upwards until the total number of particles. So because I have this nice little integer, what I can do is do a simple multiplication, which means that I'm going to get every single particle and put it at a specific distance, but this distance is not going to be a fixed number. It's going to be this a number multiplied by the index. So let's go here and select math. Let's get math add. Select it and say I want to add or I don't want to add. Maybe I want to multiply. So I'm going to multiply my index 0, 1, 2, 3, blah, blah, blah. And I want to multiply it not by a real number, which is any number we can imagine. 0, 1, 2, 3, 3.5. Any number that can be expressed by a fraction, something like that. Anyway, and I'm going to say I want a vector. And the second input, I can drag the constant, or I can set it there. So I'm going to leave this unconnected. I want to multiply the input, 0, 1, 2, 3, 4, 5, and so forth. And I'm going to put here 10. So in theory, what I'm doing now is particle 0, it's going to be at position 0 times 10, 0, 0, 0, right here. Particle number 1 is going to be 1 times 10, 10, 0, 0. Particle 2 is going to be 2 times 10, 0, 0. So we can have particles along this line every 10 units. So let's try this. Take the output of the multiplication, put it in the position, rewind, and advance, advance, advance. And yes, we did it. Now you will see that the particles are generated, and after their generation, they're being moved over here. Now, this movement happens on the next loop. All right, remember that. Because if you're doing any kind of animation with your particles, you will find that on frame 0 they'll be born here, and on frame 1 they will move a step ahead, or 2 steps or 3 steps, and so forth. So if you're trying to generate your particles in these positions, this is not the way to do it. You need to do it upon birth. Because, for example, if you're doing something which has subframe motion blur, what's going to happen, it's going to show that the object assigned to the particle, because we can't directly render particles, anyway, that's another story, is going to move from frame to frame because it's born here and then it's transferred here. I'm showing you this just to explain the methodology. So if you're actually trying to generate particles in this configuration, there are a gazillion other ways to do it, and they're going to be correct. This is just a way to show you how you can manipulate a particular piece of data after the particle is born. Excellent. So with that out of the way, let me just show you very quickly other ways of generating particles, and yeah, we're going to be over with this tutorial. So I'm going to select all these and delete them, and I'm going to delete the p-born, and you need to rewind and sometimes press play or something and rewind again. You may have to do it at least once if you have any particles still in your scene. Fantastic. Let me close all these, and let me open it again. Let's go back to Thinking Particles, and let's go to the generator. Very quickly, that was the p-born, the most basic way to generate particles. The easiest way to generate particles is the p-matter waves. Now, the p-matter waves, I'm going to give you a very, very, very quick overview. Allows you to use any mesh object, so you can only drop a mesh object here, an editable object, no generators or anything like that. You can put polygon selections, UV tags, and select all sorts of different ways to generate the particles, even by selecting the lights, a set of lights where particles are going to be born wherever there is light on an object, and that's a very interesting thing. You can do great effects. The birth type is the same as everything else. You can have different types of births, textures, lights, and so forth. You can put noises here and generate from a surface. Anyway, life, again, you can change the life based on a texture or light or something like that. The speed, so here, besides the other attributes we had, which was the life, now we have speed, so they're going to move upon generation, and again, we can control these things. We have size over here. Then we have distance from the surface it's emitting, and direction variation if they're moving in all sorts of different variants. So this is a great way to create thinking particles when you're going to need these attributes to be set right off the bat. The p-born is if you want a very, very simple way to generate particles so you can have full control over what they're going to do. Not that you can't do them both ways. For example, you can set all the speeds and everything to 0. You can make your mesh object very, very small, and it will seem as it's emitting from a point, and so forth. It's up to you. This is a much more complex generator, and it allows for more effects. So, done with you. The last way, which is an interesting one, is called the p-storm. And the p-storm, let me make it a bit bigger, it generates particles, and these are all the parameters. First of all, if I press play, you will see that it creates a circular or a rectangle emitter. And one thing you need to remember here is that although it's been applied to this null, nothing is related to this null. You can see nothing really happens. Even if I move it, the generation won't change. It will always point over there towards the plus Z. And the reason is that the p-storm, we do have it assigned to null, but it takes into account none of the null's position, scale, or rotation. In order to control how the emission happens, then we actually need to connect our p-storm to an emitter position, and the emitter alignment, which is basically the rotation, we need to connect it with something else. So you can always connect them to this one or a new one. I'm just going to create a new one. I don't know, I'm going to make a cone, and I'm going to point it to the plus Z, so we have some sort of context as to the direction. And I'm going to drag the cone here, and I'm going to expose the global position, and that is to connect the emitter position. Command double click to do that, and then I'm going to expose the global matrix. I could sit here for half an hour and explain exactly why, but I won't. So global position here and global matrix here. Every Thinking Particles tutorial tells you about this, so I'm not the first. Now if I rewind and press play, you will see that it's still emitting from that rectangle or circle, but the orientation, so go to rotation, the orientation is that of the cone, okay, and the position. So you can use the cone as a control object. You can make a little arrow. You can just use the express tag itself. So if I take this and drag it here, now I can get rid of the cone and everything will happen based on this. Okay, I hope you knew that. You can drag anything on a node if it references an object, and it will change to that object. So there you go. The p-storm can give you the birth count, the birth number, particle birth, and all that. And that is, but particle birth is what you would connect to something, for example, to get the data and so forth. It's just like the p-pass, and as I told you before, it's the one related to the particles that are born at that specific frame. Anyway, so now you have a sort of a fundamental basis to generate particles using Espresso, and how to read some data, how to write some data, and how to do some very, let's say, baseline troubleshooting. Now, one thing before I close this video, because I wouldn't like to make another video about this, is the following thing. I'm going to rewind this. I'm going to get rid of this guy and this guy. And what I'm going to do, I'm just going to zero these out because I've got OCD. Now, look at these particles. Maybe you need to rewind and press play a couple of times. And there you go. That happens sometimes. There's one more way to generate thinking particles, and that is by using MoGraph. If you select a matrix object, it has a generate parameter which says matrices only, which is just positions in space, or thinking particles. And you can tell it what group to make them generate in. I think I can make this invisible. There you go. So now we can see the thinking particles. If I press play, nothing else happens. The total number is always based on the number of clones we are creating. So we can use this, for example, in object mode, and go grab a sphere, tell the sphere to be the object. You can see now it's on the surface. I can turn this off. Oh, if it turns off, it doesn't work. There we go. That's what I wanted to do. I can do a distribution on volume. So now I'm generating inside the volume and so forth, and how many particles we're going to have, and so on and so forth. So this is good because just like the p-born, it just generates the particles as points. And if I want to control them, then I have to go inside Espresso. But as far as generation is concerned, we can use the matrix object with all its goodies here to generate my thinking particles, and then just take control in Espresso and do whatever you want with them. Okay, so I hope you like this tutorial, and very soon I'm going to finalize the one about creating fire and smoke and all that. And yeah, hope you like this one. Toodaloo.